Let's say you wanted to dash forward, but at a 45-degree angle. How would you do that? Would you use get actor forward vector? Or maybe get actor right vector? That still wouldn't give you the 45-degree angle that you need. The rotate vector node is an interesting one. So for example, if I want to rotate a mesh in a circular motion, I can use the rotate vector. You simply input the vector that you want to rotate, and then the rotation axis you want it to rotate around. Nothing is happening. That's because the world location is set to 0. If I move it a little bit on X or Y, then it will move. If I move it further away, the diameter of the rotation axis will increase. It doesn't have to be world location. I could also use relative location. I'm currently running this on tick, so it keeps adding 1 per frame. If I set it to 90, it would just move like this. This means that the higher we set the value, the more it will move on that axis. Now I've only moved the mesh on X. If I also move it on Y, the same thing will happen, but the circle will be located differently. If I change direction, the movement direction changes. Now they're all moving at the same rate. Since I changed direction, it doesn't care about the Y value anymore. Rotation always happens around a pivot. The further away we move from 0, the bigger the circle diameter. You can simulate the same effect by adding a mesh, and then by adding another mesh, parenting it to the first mesh, and then moving it. The same thing is happening when using the rotate vector. The difference being that here we're rotating the mesh, while the rotate vector does not rotate the mesh. We tell it to rotate around the z-axis. The z-vector will stay the same and use the x and y to create a circular axis. If we change axis, the same will apply to that direction. So this is good and all, but unless you're making spinning platforms, why do you need to know this? Here's the thing. Even though I'm demonstrating the node using this mechanic, the rotate vector is supposed to be used for direction vectors. I've covered the difference between location vectors and direction vectors in another video, but simply explained, direction vectors point somewhere, while a location vector is a point in space. This brings us back to our dashing example. Since we want to dash towards our character's forward vector, but at a 45-degree angle, we need to use our character's forward vector, or alternatively, the right vector. Because we're rotating on Z, the angle remains the same. But if I do the same on the x-axis, the result will be different. The arrow will point up or down depending on whether the forward vector value is positive or negative. This isn't exactly the most popular node, but it can be used when you want to make the character's movement direction relative to the camera, or launching an enemy based on what direction the bullet hits it, and so on. So that about covers the rotate vector. But what about the rotate vector around axis? Don't let the look fool you. It's pretty much the exact same thing. There's only one difference. I'll simulate two meshes. One mesh uses the rotate vector node, and one using the around axis. The first input is the same as A. The angle variable can be treated as the amount you want to add, same as the rotation you would add here. The axis is the direction to rotate. I'll move it slightly so you can see. But they're both doing the same thing. Nothing will happen. To achieve the same result, I will need to increase the angle. Like I said, pretty much the same. But look what happens when I add an axis to both. Now they're spinning differently. We can change what direction the axis is facing. We can't independently change the speed. But on the rotate vector, we can. You can make an individual axis rotate faster. This can give you some twisted rotation values. This can be very useful for bullet spread, for example. So if you only care about one axis, use the angle node. If you want additional control, use the rotate vector.